Welcome to today's Explainer. We're diving right into this beautiful, completely invisible system that surrounds us literally every second of the day. We're going to unpack the fascinating science of air, drawing from KSSM Science Form 1, Chapter 7.
Here's our roadmap for today. We'll cover the composition of air, the oxygen and carbon cycles, the science of combustion, extinguishing flames, air pollution, and wrap up with a quick chapter summary.
All right, Section 1, Composition of Air. What exactly are we breathing?
Seriously, take a deep breath with me right now. Just hold it for a second and let it out. So what exactly was filling your lungs in that moment? You know, it's not just empty space, and it's definitely not just a single gas. It's actually this incredibly delicate mixture. And here's the cool part. Because it's a physical mix and not a chemical bond, we can actually separate its ingredients using physical methods. There's a process called fractional distillation, which basically cools the air way down until the different gases turn into liquids at totally different temperatures. If we look at the exact recipe of our atmosphere, it's a highly specific balance. A massive 78% of it is nitrogen, 21% is oxygen, 0.97% is made up of inert gases, and just 0.03% is carbon dioxide. Throw in a little dash of dust, some water vapor, and yeah, even invisible microorganisms that can sometimes cause fevers or sicknesses, and you've got the whole shebang, the air we breathe every single day.
Now you might be wondering, how do we actually know that oxygen is exactly 21%? Well, a remarkably simple experiment proves it. If you place a candle in a jar that's marked into fifths right over a basin of water and light it up, the flame is going to consume the oxygen inside that jar. Once the oxygen is completely depleted, the flame dies out and the water naturally rises to fill the vacuum. And guess what? It stops precisely 1/5 of the way up. Since 1/5 is 20%, it gives us this incredibly close, super satisfying visual proof of that 21% figure.
Every single ingredient in this atmospheric recipe is absolutely vital for daily life. I mean, oxygen fuels our cellular respiration and combustion engines, carbon dioxide allows plants to photosynthesize, and surprisingly enough, it's crucial for fire extinguishers. Then we have nitrogen, which is a really important cooling agent and helps create fertilizers. And what about those inert gases? Well, they give us helium for hot air balloons and argon, which actually prevents the little filament inside light bulbs from catching fire. Pretty neat, right?
Moving on to Section 2, Oxygen and Carbon Cycles, Balancing the Recipe.
So with billions of living things breathing and machines burning fuel literally every single day, how in the world does the planet not just run out of oxygen? Well, it all comes down to these continuous cycles working in perfect harmony. Healthy green crops absorb carbon dioxide and release fresh oxygen through photosynthesis. But on the flip side, animal and human respiration, natural decomposition, and combustion, like emissions from a huge factory, consume that oxygen and return carbon dioxide back into the atmosphere. It's essentially nature's ultimate continuous recycling program.
Okay, Section 3, the science of combustion. Let's look at this high-energy reaction. Combustion is really just the scientific term for fire. It perfectly describes the reaction that happens when a substance is heated up and aggressively reacts with the oxygen around it. And this chemical reaction always produces two very distinct things: heat energy and light energy.
The really crucial concept to grasp here is something called the fire triangle. Basically, a fire absolutely cannot exist unless it has all three of these specific ingredients. You need oxygen from the air to sustain the reaction, a fuel source to actually burn, and enough heat to spark and maintain the whole process. If you take away even just one of these legs, the fire literally cannot happen.
That brings us to Section 4, Extinguishing Flames, Stopping Combustion in its tracks.
If you understand the science behind that fire triangle, you instantly hold the secret to safely stopping combustion. Firefighting is really all about knocking out just one leg of that triangle. For instance, you can use the cooling method, which removes the heat by spraying water. Or you could use the covering method, where you literally starve the fire of oxygen by throwing a fire blanket over it or spraying a layer of carbon dioxide. Alternatively, you can just reduce the fuel by physically taking unburned flammable materials away from the heat source.
But keep in mind, different fires require completely different weapons. For solid fuels, like wood or paper, water works perfectly by removing the heat. But for liquid fires, like an oil fire in the kitchen, or gas fires like propane, you absolutely must use foam or carbon dioxide to smother the oxygen. If you sprayed water on an oil fire, it would violently spread the fuel everywhere, which is exactly what we don't want. And for burning metals, things like magnesium or potassium, you strictly have to use dry sand or a specialized dry powder.
Of course, the absolute best fire extinguisher out there is just plain old prevention. That means taking some personal responsibility in our daily lives. We've got to keep flammable substances far away from heat. Definitely avoid overloading our electrical outlets with too many plugs. Make sure we install reliable smoke detectors and alarms in our homes. And always ensure that items like matches and lighters are stored safely out of reach.
Let's jump to Section 5, Air Pollution. What happens when we disrupt the recipe?
Now that we've got a handle on the micro reactions, let's zoom out and look at the pretty devastating macro consequences. When unchecked, factory smokestacks and heavy vehicles pump massive amounts of pollutants, stuff like soot, thick smoke, CFCs, toxic lead, and carbon monoxide right into the sky, we aren't just making the air look dirty. We are fundamentally altering the very biological systems that keep us alive.
And the consequences are just heartbreakingly real. Excess carbon dioxide basically acts like this suffocating blanket, triggering the greenhouse effect and global warming that is literally baking our Earth. Then you've got other pollutants that mix with moisture in the air to create acid rain. That corrodes our buildings and absolutely poisons our agriculture. Meanwhile, those CFCs cause ozone depletion, which strips away our planet's natural shield against harmful, dangerous radiation.
But hey, the story isn't over, and we actually do have the power to fix this interference. We can protect our air through the really strict enforcement of environmental laws to stop things like illegal logging and unchecked factory emissions. We can educate the public, we can push forward and utilize green technology, and we can commit to mass reforestation. By simply planting more trees, we naturally repair and support those incredibly crucial carbon and oxygen cycles.
Finally, Section 6, Chapter Summary. Let's review air and combustion.
So, from that super precise 21% oxygen mixture that fuels every cell in our bodies, to the fascinating physics of the fire triangle, right through to the really urgent crisis of industrial pollution, understanding the science of our atmosphere is absolutely the first step to saving it. To sum it all up, air is a delicate mixture. Natural cycles balance it. Combustion consumes it. Pollution destroys it. But our education, our laws, and our green technology can protect it.
I want to leave you with this final thought today. The air around you is this invisible, totally beautiful masterpiece that sustains quite literally every single moment of your existence. It's our planetary shield. It's our shared breath of life. So knowing what you know now, what will you do today to protect your piece of the sky?